So in this video I'm going to be showing the process that I am following to generate a grid for an infinite wing, for which I need periodic boundary conditions at the root and the tip of my wing. So to do that, I first import my geometry. I'm going to convert this to meters, and then I'm just going to change the display of my database so that we can see that we have a wing. Next step that I'm going to follow is to create and assemble of the model. I do that and I successfully achieve that task. And the next step is that I'm going to be generating my surface mesh. To do that, I'm going to predefine an average spacing of 0.01 according to my flow physics. And next, I'm going to generate my domains on my database entities. I'm going to select an unstructured mesh and create on my model on database entities. I'm going to follow what the tutorial is suggesting for the connector joint angle. I'm going to pick 30 and I'm going to say OK. This successfully generates the grid or my surface mesh on the wing, and we can see this better by just hiding the database, and indeed we have our domain here. As I mentioned, I've been having trouble to generate my far field, and the way to work around this problem is that I erased my wings root domain. So when I jump into create automatic volume mesh, I can generate a plane exactly what I needed, which is at my wings tip. So to do that, I'm going to select my domains. I'm going to create an automatic volume mesh. I'm going to generate the boundaries. I'm going to select an unstructured mesh. The shape is going to be a box, and the center is going to be relative to my model's edges. So if we pay attention to here, what I would need is that W1 lies exactly here at my wings tip. But if I attempt to do that, for instance, I will need my far field to be 500 chords away from the body, so I'll do that. 500, 500, and then over here, if I try 0, I run into the issue that I must exceed at least 0.002. Then I select this to be 500, and I modify this. If I select the minimum, then generating the volume mesh is going to take a while. So instead, I just do maybe 50. I'm going to be doing the boundary mesh, boundary layer geometric growth. The wall normal spacing that I would need is 1 e to the -5 approximately, so I set it like that. And boundary condition seems to be okay. As I mentioned, automatically here we generate our symmetric boundary, and the boundary condition seems to be alright. Wall for the wing and symmetry for the symmetry plane. So we come here, we create our volume mesh, and this is going to successfully generate one domain that is going to be lying exactly at my wings tip as desired. So after achieving this, we can see that indeed we generate this volume mesh. But again, this is not what I need, so my next step is going to be to erase all the block, the newly created block, the domains that I don't need, and the connectors. So I'm just going to select everything here but my wings tip domain, delete, and of course in this case I will also need to erase the domain that I wings tip. So I'm going to erase this. My next step is to take my domain lying at the wings root. I take it and then I create periodic translate, and I will need it to be here at 0, 0, 0.3 is the offset vector. Okay, so I successfully generate my symmetry for my periodic domains. So the next thing that I need to do is to create the top, the outlet, the inlet, and the bottom domains. So to do that, I'm going to pick a connector, but for that, let me change the average spacing to 0.5, just to get around 656 points in my connectors. So I come here to my connectors, I close this corner, I close this other corner, next I focus on this corner, and finally we can come to our last corner. Okay, just to make sure that I don't have a lot of points. Indeed, I have 7 points, including the 2 at the boundaries. So my next step is to generate domains at those inlet, outlet, top and bottom domains. So I'm gonna select this, I come to this other corner, I select this, I come to my other corner, select all of them, and finally the one that I'm missing. And this is gonna generate in theory 4 new domains, each one pertaining to the top, bottom, inlet and outlet. So I do that, and I can see that indeed I went from 4 domains to 8 domains. So that's okay, that's something that I like. On top of that, I see that my grid has no free connectors and nor non-manifold connectors, so that's alright. That enables me to be ready to generate my block. So this is what I'm gonna need. Create, assemble special my block. I'm gonna do an automatic. I'm gonna create the baffle faces as well, and then I'm gonna be assemble my domain. Okay, and I successfully generated a domain that is pretty close to what I want. It has 2 domains that are going to be my periodic domains, lying exactly at the wings tip and at the wings tip and my wings root of my model. So my next step is to take this block, and this enables me to go to T-Rex. So the first thing that I need to do is to assign boundary conditions. So the newly created domain needs to get assigned to a condition. So this is going to be symmetry alongside both that I have, the front and the bottom, and the front and the back, the tip and the root planes. And then I'm just missing the inlet outlet top bottom pair. I highlight them here in white, and these are going to be isotropic. And just to make sure that my wing is getting the wall, I see my wing. Let's say that I want a maximum of 50 layers, 1 full layer. We're going to be using the 1.2 growth rate, and finally we can initialize our T-Rex. Right now I'm moving forward with apparent no issues. So, fine. After this, I get stuck here for a while. I get that the average growth rate on matched domains is above what I wanted, which is 1.2. This is 1.21. After a while, then I get this message in return, which says 1 block failed to fully initialize and it's incomplete. And then I have this problem, which is unable to recover boundary edge, and apparently the problem is somewhere here. I've moved some parameters here in T-Rex, say the max number of layers mostly, and these jumps around between the trailing edge and sometimes at the leading edge as well. I get this message. Yeah, this is where I'm stuck. Hopefully you can help me with some feedback. Thank you.